So far, we were discussing uniform circular motion. In non-uniform, the velocity will always be variable. Not only the direction, its magnitude will also be variable. That means one acceleration is always along the tangent also, that results in tangential acceleration. If it is a variable circular motion, means along with centripetal force or acceleration, there has to be one additional acceleration along the tangent. This is acceleration towards the center, that is called centripetal force. For this, we consider the example of a simple pendulum. This is revolved in vertical circle. There is one string, there is one bob string. It's commonly known for the tension produced in it along its length, and the bob that has the weight. See, this is being rotated like this in vertical circle. Here, the weight will be acting downward. Weight. I would change the color of the pen. Weight is acting downward, and this is tension. Tension is always along the length of the string. Wherever the string you consider, it will be along the length. Tension is here. Weight is also along the same direction. So we have considered the 2 points, that is highest and the lowest. We have considered the two forces that will regularly be present throughout the motion. We might consider different situations of the string. In this case, one must be careful that weight is not going to change any time, that will remain constant. But since the height will change, potential energy will change, kinetic energy will change, and so the speed. If the speed is changing, it becomes variable circular motion. Speed changes, different centripetal force mv square upon r will be needed, and to adjust this varying centripetal force, tension will also be variable. So in this motion, T and V both are variable, and we have to take care. We have to take into account this thing that T and V both are variable. We consider one particular point here. See this one. This is at angle theta with the downward vertical. This is general point P we have chosen just to find a formula that would be applicable in general. See, mg likewise as here. Mg have been resolved into two components, and T is here, this thing, T. T and mg cos theta, these are along the radius responsible for centripetal force, and that should be written as T minus mg cos theta mv square upon r. This is such an equation that could be used anywhere by putting the different values of theta. You may choose any point. For example, if you consider theta 0, you reach over this lowest point. If you consider theta 90, you are here at this point. Similarly, by taking 180, you will be here at the highest point. So it could be remembered. Sometimes the form is also changed. This becomes of other format. But this is general equation for being used at any point in the entire discussion. But we'll go one by one. Let's start from the highest point. At the highest point, you see, if you are having pendulum in your hand and you are causing its rotation, there is no upper limit till the string is broken. You might increase to any value. It is possible. The motion is possible unless this string is broken. We need a lower limit of velocity. Beyond, if we go further lower, it will not continue. So at every point, we want to know what is the minimum velocity that will be responsible for motion. That's what we are interested in. We want to find what is the minimum velocity or the tension at the highest point so that this motion could take place. Now, when you are considering minimum values required, you must be knowing that in a string, minimum value of tension possible is 0. In the string, the tension could never be negative. So let's consider this thing that at the highest point, the tension is 0. Prior to that, you see two forces are there towards the center, T and mg. Obviously, they both will play the role of centripetal force. But since you are considering the minimum values, let's put the minimum value of tension that I told you is 0. If this is 0, what you get? V equal to root GR. One very important result we got, that minimum velocity at the highest point should be this much. Sometimes enthusiastically this is also termed as critical velocity. Here in entire discussion, if you use the term critical, it means the minimum required. So at the highest point we got two results. The tension at the highest point should be 0. The speed at the highest point should be root GR. What does it mean? I'll reiterate. When we say the minimum velocity at the highest point, it simply means if you use the velocity at the highest point, root 2GR, root 3GR, root 4GR, there will be no kind of difference. It will be continued. The motion will continue. But if you want to decrease the velocity less than this, then the motion is not going to be completed. This is the meaning of critical velocity in circular motion in vertical plane.